All right, let's talk about particular concept that is very important. Networking. That concept, network devices. What network devices are. Very quick. How they work. An understanding of network devices will help you, have certain things clarified when you networking, so you know certain you understand something. So there are um, there are five network devices. There are a lot of them devices themselves, but five major network devices that you and every other device out there based on one of these network devices that I'm about to share. First one, a repeater. Repeater. We're going to look at orb. So repeater, orb. Number three, bridge. Number four, switch. And number five, router. So there are five network devices that you need to know, and every other device out there is based on one of these network devices. There are a number of these in the virtual world. You'll be seeing some devices, but then they are based on one of these. Let's start with the first one, the repeater. So what is a repeater? So what happens is um, when two computers connect. Let's say you have this computer here. You know that what networking is when a computer A, for example, tries to connect with computer B. When computer A and computer B are connected, then you say you have a network. It's simple. Maybe you use a wire to connect these computers together. You have a network. Wire connected, two of them, you have a network. What happens is depending on the distance. If the distance of B is so far away from A, then that means you're going to need a very long wire. So let's do that here. Let's put A here. Then you have the wire that connects the two computers together. You have B. These two wires, or this wire rather connects computer A to computer B. And so because of this connection, you have a network. In other words, a network is a connection of two or more computers. When two or more computers are connected, say you have a network. So now, because computer A and computer B are connected over a very long distance, packets of data sent from A will have to travel through this wire to get to B. But the problem with packets of data is that the longer the distance, the higher the possibility of a data decay. So data decay is when the data transferred from A gets decayed or get destroyed over time when it gets to B. So we call that data decay. So data decay can occur when the distance between two computers is long. So as the data transfer, as it goes along this wire here, it starts to get decayed. It starts to go down. Maybe you've got a very long, you have a data packet as it moves on, starts to experience decay, so that the data may not get to this point the way you intend it to get to it. So that's data decay. Now, to prevent data decay, network engineers invented what we call repeaters. So repeaters are devices that are installed on the wires, on the connections like this, so that when the data gets to the repeater, gets magnified, gets magnified, and then it gets magnified so that it will not decay. When it gets to this point, that gets magnified, because decay means it gets reduced in quality. And so when it gets to this particular point, the first repeater here, data gets magnified so that the decay does not occur. Or even if is going through decay, gets magnified to the point that k is cancelled, and then you have another repeater here, then you have repeater. So along the wire, along the connection between A and B, there are what we um, call them repeaters. So repeaters prevent data decay. Repeaters prevent data decay. It's as simple as that. So from A to B, you've got repeaters installed in such a way that the data does not decay as it travels along that wire or along the network, the utility or the binder between the computer. That data does not decay as it travels along that wire. That is job of repeat. So the first thing you need to understand here, that data decay prevents data from being reduced. So it increases the validity or the efficacy of that data between from the source destination. Now, one thing about repeater is that they are single ported. They are single ported, which means that they are single ported, which means that the port is only on one side. So got the wire here, got the A here, and you have your repeater installed here. This then the port here. So you have this thing plugged in. They are single ported. So this is the port. Okay. In other words, repeaters are single ported. Repeaters are single ported. That's because there is a single port. This is the repeater here. So that means the wire comes with a set of repeaters, and you have the connection that yes, they are single ported. They are single. That's the meaning of repeaters. They are single. As the signals travel along the repeaters, the signals are regenerated. So let's talk about some highlights of repeaters. What are the highlights of repeaters? Number one, repeaters. Highlight of repeaters. One is they prevent data decay. That's number one. Number two is repeaters are single ported. Repeaters are single ported. Repeaters are that things you need to understand. Number three, they they regenerate signals. They regenerate signals. That's how they actually prevent data decay. They regenerate so data decay does not occur because they regenerate signal. Number four is that they are usually they are installed or they are present between two computers. Now, I've given you that example already. You've got a computer here, A, and you have a computer B. They're usually installed here, and so you can't have another computer because a single port. So it's not possible for you to have another computer where you have it in between. So they are single ported, so they are installed or they are present between computers. Present. So let's talk about the next device, the next network device. Next network device that you need to know about is hub. Hub. Next one is a hub. Next, hub. The next one is hub. So the next question is that how does a hub to start with, hubs are multi-ported. Orbs are multi-plotted. So, in other words, a orb is a repeater. A orb is a repeater that is multi-plotted. A orb is a repeater that is it's just a repeater, but it is multi-plotted, and this means that it can exist between two or more computers. It means that it can exist between two or more computers. So you can have a computer A here, and then you've got a computer B here, and then this computer A and B, they can all be connected. So I have like a computer C here. What happens is that you can have all these computers connected here. So I'm going to remove this. This is not important. So you have this connection here, and you can see that it is multi-ported. You have this port here, you got this port here, you got this port here, you can have another port here. Now, it depends on the type of orb we are dealing with here. And all these computers here are connected to this orb, what we call a orb. What we call a orb. So there are different switches or different ports on this orb. So this is the first port, P1, P2, for example, P3, and this is P4. So you have 4 ports on this orb, and they are all connected. So a orb is a repeater that is multi-ported. A hub is a repeater that is multi-ported. So in this network, all these computers are connected. The network looks like this anyway. You have something that you are within a network. Yeah, network here. Remember what a network is. You've got a bunch of computers connected. And those so now you have these computers are connected to a single port, a single hub rather. And we said that a hub is just a repeater. Difference is that a hub takes it to the next level, such a way that the hub itself is multi-ported, meaning that it does not only take 2 computers, it can take more than 2 computers. And it depends on the hub you are dealing with. And have 3, 4, 5, 6, 7 computers connected to the hub. Okay, so the next thing we want to take a look at is what is the thing that the hub does? How does the hub works? What happens is that when A sends data, sends packets of data, we already know that data decay will be prevented because hubs are actually repeaters. So data decay will not occur. So when A sends information to B, let's say A wants to send data to B, sending B to, what happens is that C will also receive a copy of that data. So A wants to send data to B, C will receive a copy of that data. A wants to send data, the A sends data to B, the A sends data to B, A sends data to B. That's the first thing. But then C will receive a copy of that data. C, a copy of that data. What I'm saying is that the data you are trying to send from A is going to B, but C will also have a copy of that data, even though C does not, this data is not intended for C. So the data you are sending to B will also be received by C, even though C does not own, even though the data is not intended for C. Understand? So you're sending data to B, but C will also have a copy of that data. So if C is sending data to A, B will also have a copy of that data. If B is sending data to C, A will have a copy of that data. So computers that don't really need what you are sending will receive that data, because this is how orbs work. So orbs work in such a way that computers that you do not intend to send data to will receive that data. So B, it is not intended that computer B receives the data that A is sending to C, but B will receive that data anyway because that is how orb works. So this is the limitation of orb. And so if you have like thousands of computers on a network, that means that, and then a computer is sending data to just one computer, that means the remaining 998 computers will receive that data, even though the data is not meant for them. And that's even though I know that it is difficult for you to see a hub that has 1000 ports, but I'm just using that as an illustration. Let's say you have 10 computers connected to a hub, for example. One computer is sending data to computer B on that network. So that means 8 computers will receive the data that they are not supposed to receive because you're using a hub. So this is a disadvantage, or it's a downside of hubs, and that is exactly what hubs do. So hubs are multi-ported repeaters. That means that they prevent data decay. That's number one. Number two is that because they prevent data decay, they work by uh, you know by magnifying the signals that come from the destination computer to the from the target computer to the destination computer. So that is or from the source computer to the destination computer. That is what hubs do. So let's move on to the next type of network device. Um, so let's go on to the next type of network device. So the next one is bridge. Bridge. So the problems of orbs, the problem or challenge presented by orbs um, is solved by bridge. What happens is that bridge solves the problem presented by orb. So we said that from computer A to computer B, if the computer sends packet of packet of data from to another computer, other computers within that network will receive that same data, and that is not supposed to be. So what bridges do is that bridges will prevent that from happening. Let's see how to represent that with a diagram. We've got this computer A, got computer B, got computer C, got computer D. What happens is that a bridge will can be installed. The bridge here. So this computer is on this bridge, and this computer is also. So bridge simply prevents data that are not intended for a particular. So prevent a computer from receiving data that they're not intended for it. So if A wants to send to B, means C and D should not receive a copy of that data. That's all. That's all bridges do. So A wants to send data to B. B will receive that data, but C and D will not receive that data. It's as simple as that. So a bridge is a modified orb that prevents data from being sent to computers that do not deserve that data. As simple as that. All right. Next one is so we that bridge. So the bridge, tries to solve the challenges of hub by making it impossible for data to be sent to where it is not intended sent to. You are from A sending to B. C and D will not receive that data. Only B receives that data because that is the target, that's the destination of that data. So the next one we're looking at is so these are the three the three devices. We've got repeaters, we have orb, and we have bridges. And you've seen the challenges that exist and all of that. The next type of the next type of networking device that you need to know is switch. And the way switch works is switch allows data to be transferred within the network. Let's say you have a network here for the computer. That's here. This A, B, E, F. So if a computer is to send data to B, so when the computer wants to communicate with another computer in the network, switch is what is used. Switch is a better alternative of because switch allows all the computers to be connected together. So orbs are usually limited in terms of the number of computers that can be connected, but switch takes it to the next level. Switch allows you to be able to send between send information between the network, within the network rather. So you have data being transferred easily in the network. Another thing is that a switch is very smart to know how to send that data to another computer without without delivering that data to the computer that does not deserve it, or that is not the data is not intended for. So you have A sent to B. You have if B wants to send to F, that will be using switch. So transferring of data within the network is made possible by switch. So next generation bridge. Switch takes bridge to the next level, and it makes it possible for more computers to be added. So a switch allows you to send data from one computer to another within the network. The important thing to note here is that switch is important within the network. Allows computers to transfer packets of data within the network. Within here is the key, within the network. So let's take a look at what routers do. So routers, on the other hand, makes it possible for packet of data to be sent from one network to another network. We have a network here, we have another network here. We got A and we got B. So there are computers on this network, and we have another computer here. This is A, F, and A. So B wants to send data to E, for example. It will be through a router. There will be a router here, uh, here, and then the router has what is called the two gateways. There are two, um, there are two gateways here. Network is plugged to this gateway, and then this one too is plugged to this. So these two gateway allows networks to communicate with one another. So you have when B wants to send to E, the data will flow towards the gateway here, and then received from the other end, and then be transferred to E. When B wants to send to D, don't flow through the gateway because switch understands what is going on. That's why switch is a more sophisticated than bridge. So when B wants to send data to D, a switch is involved. You can have a switch that looks like this, connected. So when B wants to send to D, it moves along the switch all the way here, cool as that. Because the switch will take a look at the IP address of the destination computer to know whether the destination computer is on the network or it's on a different network. So if that destination computer is on a different network, then that will be routed to the router, to the gateway here of this router, and then the router will send it to destination computer on the destination network. So the key takeaway here that routers they work by connecting. They allow networks to communicate. They allow networks communication. When the computer wants to send packet of data from a network to another network, routers are used. So that's where routers come in. Routers allow information to be sent from one network to another network. Now, if I'm to receive, if like I said earlier, within the network, that is where switch comes in. From a network to another network, that is where router comes. Important thing to know about router is that there are two gateways in there. You have the this one and this one, the input and the output gateway, and each gateway has an IP address. So you've got a router that looks like this, and you have this particular gateway and this particular gateway. So this one we have an IP address of its own, and this one we also have an IP address, separate IP address. So routers are special in the sense that they have two IP addresses. Because a router is also a network device, or it is also a node on the network, it will also have its own IP address. So whatever you send in, this computer B that wants to communicate with computer E, for example, the target IP address and all of that will include, the IP address where the B is going to send to will include, the IP address of the router. And the router knows exactly where to route that request. That is what you understand. These are the important network devices that you need to know. There are other devices that the network uses, but believe me, all these other devices are based on the ones that we've discussed already. So again, take your time to go through all we've discussed and let me know if you have questions.